In this case, we have received some of the terms containing power of x, y, z on the xyz itself, abc itself, and some power or some values of a and b, a, b, c. So let me do these all equal to, let me assume all equal to k. Now, different way we can adjust. If I want to adjust first that log x equal to k times of b minus c, then multiply both side by a. So a log x means log of x to the power a. That can be written as k times of ab minus ac. Same thing I want to write in this similar way. Similarly, whenever log y is equal to k times of c minus a, multiply by b, and we can find it out log of y to the base b, y to the power b equal to k into bc minus ba. This is our first relation, this is our second relation, and similarly we can write log of z equal to k times of a minus b, and again by c if I have multiplied. So log of z to the power c equal to k ac minus bc. Now this is the third. What I will do, I will add 1, 2 and 3. Then what happened? Left hand side it would be log of x to the power a plus log of y to the power b this way. So log of x to the power a multiplied by y to the power b multiplied by z to the power c. Left hand side will become like that, and right hand side is happening what? Right hand side is k times of all of the data it is appearing. First one is appearing as AB minus AC, then second one BC minus BA, third one AC minus BC. Now please see that BC get cancelled, AC get cancelled, AB get cancelled. So it should be nothing but equal to 0. Once it is 0, that can be written as log of 1. So I can find x to the power a, y to the power b, z to the power c is equal to 1, as log of this equal to log of 1. So x to the power a, y to the power b, z to the power c equal to 1, it is appearing. We can try on adjusting one after the other by this way, and we can see these others we have not been able to find similarly. Now if I consider the same thing, we can find that if I multiply as per the requirement of others like b plus c, then it is b square minus c square. Then in this case, it should be b square minus c square. C plus a, like that. Means what it would be happening? B square minus c square, c square minus a square minus b square. Same thing, D. Let check it out, option D. Wherever I am multiplying by b square plus bc plus c square, what will happen? For first, if I do it, then it would be log of x to the power b square plus bc plus c square. and this one will be k into this multiplied by b minus c. So it should be k into b cube minus c cube. Same thing by second one, c square plus ca plus a square. If I multiply, it would be log of y to the power c square plus ca plus a square, and that would be k into c cube minus a cube. Same thing if I do it by this one, similarly, then it would be by which value I am multiplying, a square plus ab plus b square, and that would be log of z to the power a square plus ab plus b square, and this one will be k into a cube minus b cube. Now you please see that 1 2 3, if I add it up, right hand side will be equal to 0, so it should be 1. That means our again this option d, it is actually satisfying. Achha, if I try to check this one, then what I have to do, b plus c. So in place of our equation 1, it should be b square minus c square. So if I go on adding, then right hand side will be k into b square minus c square plus c square minus a square plus a square minus b square. What happened? Again it would be equal to 0. And again it is 0 means this is also true. So I can find it out. Our answer B, C, D, these are all true. But it is not happening for x to the power that, x to the power x. So in our first case, if it is x into b minus c, that one if I do, it is not appearing to 1. So answers which is or are always correct. So I can see that these all three are correct in this case.